So how about if somebody says do problem like exercise number 70? Here we need to add exercise, add number 8 to itself so many times, right? So they're talking about the sum of numbers 8, and it repeats from 1 through 50. Which means that if k is equal to 1, you have 8. If k is equal to 2, you have 8 plus, of course, because it's a sum. So you're gonna add 8 with 8 and with 8 and etc. lots of times. And you start at 1 and you end at 50 times. So the total will be 50 of those numbers 8. In other words, all I need is to multiply 50 by 8, and I guess we don't even need a calculator for that. We can just say 5 times 8 is 40, right? So it'll be 400 for the sum. So I hope you're getting used to this summation, that sigma, that nice Greek letter sigma that they heavily utilize here. I will be utilizing it from now and on in the next sections of this chapter. So I'm gonna take a look at the sequences that have some special pattern. So for example, if I look at the example 1 here, I notice that if you move by 2, so if you add 2, you will get 8. And if you add 2 again, you will get, actually 4 plus 2 is 6. Should wake up. And then 6 plus 2 is 8. And then another 2, we get 10. And another 2, we get 12, right? And then we get 14, and we get etc. 16, and so forth. So this is the special way to produce sequence. And they call this as arithmetic sequence. So if you keep adding the same number or subtracting, the number is called difference in terms. So if you move by the same number from one term to another, it's called arithmetic sequence. And it's nice to be able to produce more and more terms here of this arithmetic sequence, and they show various examples here, like they have for the formula for the sequence for the term. So notice that if I start with the first term with a previous example, I believe we started at 4, right? And then we produced 6 by adding 2. Now, if I have next term, which is 8, that I produce by adding 2, I could have said I add with number 4 2 twice. So this special number difference, I add so many times and produce the next terms. So if I want to look at the following, which is 10, and looks like I could just add 2 to the 8, but I could start with the first term and say I add 2 3 times, right? So in other words, I can produce the special formula that they have here. So they say if that's nth term, then I add this number 2 n minus 1 times. So if my term number 3, which is 10, was produced by adding my first term, which is 4. It's actually A index 4. That's a fourth term. I have to count carefully. So that's the term number 4, right? 4, 6, 8, 10. That's index 4. So I start with my first term with 4 and add 3 2's to it. So I add 2 3 times, which is index 4, 1 less, 4 minus. So they trying to relate. Let me write this. They trying to relate the first term with this in order to produce a nice formula that they have here for the nth term. They say the nth term for the special type of sequence called arithmetic is dealing with the first one, and that the difference will be added so many times, which is 1 less than the index of term that I'm trying to get. So the difference is the key. And there are actually 2 things that I need to know to produce any term of this sequence. I need to know the first term, and I need to know the difference, the gap in between of those terms. And that way I can produce all kinds of results in here. And that's what they're talking about. So let me do the exercise so we can check it out. So as usual, skill building exercises. So again, I'm in the chapter 12, and it's next section, section 2 of chapter 12. It deals with a special type of sequences called arithmetic. So for example, if I look at problem number 15, that has a first term, which is 2, and now difference is 3. So my first term will be 2. To get the next term, I need to move by 3. So I will add 3 with 2, I get 5, right? And I add another 3, so I get 10. So notice that knowing the difference, you can produce all of the terms eventually. Well, it's actually infinite, so you'll never be able to get all of them, but quite a few. So they say find the nth term. So would be A index n in here. And you don't have to think too hard if you have a formula. So all you need is to get a first term 2, right? That's my A1. And then n minus 1 for the nth term. So I just use n because they didn't tell me that's term number 5 or 10. Just n term is multiplied by the difference, which is 3. And of course, I can simplify this as usual. We always try to simplify. It's not hard here. So we'll distribute that number 3 and see what the actual answer is. It'd be 2 plus 3 multiplied by n minus 3 times 1, which is 3. And here's my answer. N's term is going to be 3n minus 1. So you want to find the term number 100. It'll be 300 minus 1, 299, and so forth. So that's the formula. And if somebody says, how about 55th term here? So A index 55. Well, I will take 3 and times it by 55, right? So it'll be like 165, isn't it? 3 times 50 is 150, and 3 times 5 is 15. So it's 165, subtract 1 is 164. So you don't have to start at first term and keep adding 3 and again and again and again, because that's not going to be really a good idea. You'll be stuck with this till next day or so. So you just use the formula. That's why formulas are very popular, and this formula for the nth term is pretty much all this little section is talking about. There is one more thing, but I'll talk about it next time. Don't want to overwhelm you with this. So find the common difference in this. So that D, that was 3. How about if I try to do problem number 11 and find the difference in these terms of the sequence? So in 11, we have the sequence, which is arithmetic, they say it. And that's good to know, because otherwise there is no point to talk about the difference between terms. And I think that if you know that this is arithmetic series, all you have to do is just find the first 2 terms and subtract, and you will get the difference. So for the first term, I use n is equal to 1. So term 1, a 1 is half minus a third, right? Would that be 1/6? I'll let you do this arithmetic yourself. Find the same denominator, right? So you'll have 3/6 minus 2/6, and it'll be 1 divided by 6. So whatever it is, now you get n equal to 2 to get the second term. So I guess that's a straightforward way to see the difference. And if you wish, you can actually double check it, find another term. If you have nothing else to do, then you can always double check things. But they already told you it was arithmetic, so you don't really have to worry about this. So what you do now? From 1/2, you subtract 2/3. So I need to get same denominator. So 1/2 is 3/6, right? And I will subtract from it 2/3, which is 4/6. It's Alex, that's going to be negative. Okay, it'll be negative 1/6. So what? So we get a first term, which is 1/6. The next term is negative 1/6. So how do I produce the next terms? Well, I need to see the difference in between of these. So if I subtract from 1/6, negative 1/6, I'll actually have to add, right? Because if I subtract negative, there'll be a plus. So when I add, this will be 2 6s, which is 1/3. Right? So that's my difference in between those terms. It's 1/3, but please notice it's negative, because if I start at positive 1/6, I need to subtract 1/3 or add negative. So it's actually difference is negative. So if I want a next term, I'll subtract another 1/3 or 2 6. So it'll be negative 3 6s or half. So I'll just keep going in the negative direction. So I'll just add negatives. So just keep getting 1/3 subtracted. So the answer is difference is negative. So we'll write it someplace. 1/3. It could be negative. So what? In fact, we can see that there are sequences here that are arithmetic sequences that have a negative difference, like in exercise 20, for example. It's negative 1/3, so you'll be subtracting rather than adding, and that's fine. Difference could be positive, difference could be negative. We should not be afraid of dealing with negative numbers, right? But the key idea is to realize that we keep moving by exact same number. We're either adding or subtracting. So let's try number 23 here. All problems actually are, I would say, identical because they all go under the formula above. So if they say 100th term for this sequence, so if you have your first term equal to number 2, right? Why is it? Well, because it starts with 2. That's the first term, so it's actually clearly given to us. And now I need to know the difference, right? If that's 2, 4, 6. So dot. So we keep adding number 2, looks like, right? That's our difference. If you want to double check to make sure, sometimes people do that. It's not hard here. So you add 2 again. So if you have difference 2 and the first term is 2, well, if they want to know term number 100, well, put 100 instead of n in this formula, and you will get the answer. So all of these problems go under this formula, and in order to use it, you need the first term and you need difference. And of course, know the n, they always give you that, so that's 100 minus 1, so we're gonna have 99, right? So 99 times 2 is minus. And then I add it with another 2, so there'll be 100 of those 2's, and 100 times 2 is 200. So 100 says 200. Or you can use a calculator if you like, you can double check that. Make sure you did it right. So nice little exercise. Let me do one more, and then I'll give you a little break from all that. I hope this is interesting topic. I hope this is exciting. I know sometimes you get to deal with fractions, so people start to feel uncomfortable. You can use calculator. That's a good idea if you are not sure, just to double check the arithmetic. But I guess by now you probably already feel a little bit better about calculator. So let's see what else they have in here. And looks like we can try exercise number 35. So in exercise 35, looks like we're gonna have to solve the system of 2 little equations because we're given term number 14, right? A14. And this is -1, okay. And we're also given term number 18, it's -9. Okay, that's good. So what I need is to use my only formula that came up in this section, the one that I just used in the previous exercise as well. I don't have much choice but use this formula again. So we have a first term, A1, or I can just use A. People use letter A for convenience, which is gonna be added with what? N minus 1. So now n is 14, so that'd be 14 minus 1, right? Which is 13 actually, multiplied by difference d. That's my first use of this formula. And the second use of this formula, again, I have a plus, now we changed index to 18. Okay, so instead of 14, I put 18 because we had 14's term and the 18th term. Okay. 18 minus 1 times 2. So we need to find two things. We need to find the first term and we need to find the difference, right? And is that what they say? Find the first term and common difference, because that's all we need to describe any series. So what I can do is say that this is a system because it works with the same A and with the same D. So let me write it out again. -1 is the same as a added with 13D. You see, that's a equation with two unknowns, A and D. And the second is -9, which is equal to A added with how many D? 17. Okay. So I can eliminate letter A. Looks like there's two equations in the system. They both have same unknown letter A. Remember, we always try to get rid of one of these unknowns and we eliminate, we subtract. So let's carefully subtract. Negative numbers I need to pay a little bit more attention to when subtract. So it'd be plus, two minuses. Minus 9 is 9, minus 1 is 8. And then I subtract from 13, 17, so that'd be negative 4D. Looks like D is coming out to be negative. So D will be -2, right? Because -4 times -2 is equal to -4 times -2 is equal to +8. And then I need to find A. And for that, I will use my first equation. Looks like it has little smaller numbers. So let me replace now my letter D with whatever it is we found. Should put equals. Why do you put plus? I need to be concentrated, I guess. So I'm replacing in my first equation letter D with number -2, right? Okay, so -26 looks like. So right away I can see what A comes out to be. I'm gonna leave A here on the left side, and that 26 will bring over, so we'll add it with -26 becomes +26, right? Add it with -1 and get an A, which is 26 minus 1 is 25. So this is a pure abstract way to solve the system, to actually find this, because some people would say, oh, how do I get it? So there are possibly intuitive way to do it, but use the formula. That's pretty straightforward. And then they also say, find the formula for the nth term. Okay, how do I find the formula for the nth term if it's already found? Well, they expect us to just put instead of A and D whatever numbers they gave you. So AN, I just need to write out instead of the first term, the number we just got, 25, right? And then plus n minus 1, one say, what'd you put instead of n? Well, it's n's term, so n stays as n. We don't put anything here. We just keep n, but difference is what we found. And the difference is -2, so I got -2 to multiply by this. So it's a hard time to put parentheses. So we'll simplify. See, we always distribute this -2 to make it look nicer. So like that, and the answer will be 25. Now -2 times n is -2 times n, and then -2 times -1 is +2 tool, right? So my n's formula will be 27 minus 2n. So notice I keep subtracting. So my terms get smaller and smaller. So from 27, the next will be 25, right? And next 23, 21. So the odd numbers going down. And then eventually when you hit the 18th position, you will get -1 and then keep getting less and less or bigger negative numbers if you want. So that's the 18. So next time I will start here finding sums. Maybe it's a little bit too much. I just want you to get used to this remarkable formula. Turns out this formula is quite popular for the nth term. Everything actually starts there. And then notice we'll be finding various sums, and there is also a little formula for the sum that we saw last time, but I guess it might be a little bit too much. So next time I will find some more of these. So this section is not very long, but I still think it's deserves be split it into two pieces because it has some, again, unusual probably ideas. So I'm going to stop at this stage. No quiz, we'll just let you go. Looks like not many people are logged in today. So I hope that whoever is not here watches these little lectures. And I stop recording and I